Hello and welcome back to OpShin Pioneer Program week 3 in lecture 5. And now we will actually deploy and make use of the contracts that we have specified in the previous sections. So inside of week 3 in the source folder, head to scripts, and I am now already at week 3, and I will now execute the script for building the smart contracts. And you will see again in assets, now we have parameterized vesting and we have vesting. Note that, yeah, these are the outputs. And again, we have two scripts, one for making, for sending funds to the vesting contract, and one for collecting funds. And I think for making, there's no big surprises. We again take the chain context, we get an address. Now we get our own hash, or our own payment key hash, pub key hash, as a part of the, actually we take two parameters, one is the name and one is the beneficiary. And let's actually I will create a second account for the beneficiary so we can see that in action. And then so we load the address, and as you can see, we get the pub key hash already just from looking at the address, because that's the payment part. And then we set the beneficiary to the bytes of this hash, and the deadline as the current time plus some wait time that we specified in seconds. Python time is always seconds, but as we learned, OpShin time is in milliseconds, so we have to multiply by 1000 to get the milliseconds. And right now, in the non-parameterized version, that's already it. We have the the script path is just here in our assets vesting. Then we load the address, and as a datum we send the parameters that we defined, the bytes and the deadline, and send funds. This address is the datum. I think that's it. I'll change this to preview again, and then I will just try make vest address. Let me quickly create a wallet for Bob, which is go here, then Python 3 scripts create key pair and for Bob, and I will now fund the address. Okay, I have created the Bob address and funded it, and you might be wondering, why do we actually need to fund it? I thought we were gifting funds to this address. And the reason is that, as you might know, when we try to spend the funds, we need to provide a collateral in case that spending the funds failed and or we created a malicious transaction. So we just have to have some funds at the address with which we are trying to withdraw from the smart contract, so that that address can provide the collateral. So yeah, let's try to lock some funds. Scripts make vest. Oh, I have to go first in source week 3. 3 scripts make vest from Alice to Bob. Let's set the wait time to 3 seconds, and let's set the amount. Yeah, amount is 3 ADA, that's fine. And then send it. Okay, wait time is not defined. Underscore. Okay. Let's have a look. Okay, here's our transaction, and we can inspect again the inline datum. Now we see it's a bit more complex. We still have constructor 0, but now we have integer and we have bytes, and this is the hash of Bob's address, and this is the unlock time for Bob. So let's have a look at collect vest. Here we load the chain context, then we specify the script path again, and compute the address. Now, previously, when we tried to spend funds from the gift contract, we just accepted any datum as valid one. And now we can actually, let's actually just do this. I will run this in debug mode. And this loads the .env. Okay, we need to specify that Bob is trying now to spend the funds. So now we go through all the UTXOs at this address, and you can see now here is our actually one of the UTXOs, and this will likely be the one that we created. And what we see is that we actually see the same structure as in the txin info, if you recall from the contract. One is the transaction ID and the index, and the other field is the resolved output, which is the address which holds the funds. This is the address of our smart contract. The amount of coins, amount of value here, that's 3 levelers, and then the datum. And as you can see, we get the datum just as a raw CBOR hex. If we run utxo.output.datum to CBOR, no, datum.cbor.hex, then you see the same value that's provided here. And we know, because it's nicely destructured here in the C Explorer, that this encodes this value. But without further ado, without like checking this, we don't actually see this directly. And now we know. Yeah, okay. So I have to actually fix the script. We would handle Pluto's data and vesting params, but actually neither of this is the case. We are actually getting raw CBOR. And how we handle this is to check, is this raw CBOR? That's a definition from PyCardano. And then we actually parse datum.cbor using vesting params from cbor. We didn't define this function anywhere. It's naturally derived in PyCardano from our definition of the vesting params. And this is the vesting params that we defined in the smart contracts. And here you might be able to see how this nicely interlinks. Using PyCardano and OpShin smart contracts, we get from this definition of the contract alone, we already are able to parse a CBOR into the correct instance. So let's debug into this again. And now we take this branch and try to parse the parameters. And now we actually have the params. And as you can see, this is the values we put there. It's the deadline, this integer, and it's the hash. So yeah, this from CBOR function does the trick for us, converts the unintelligible byte string into the valid, into the params that we want to handle. And now we can actually check that the beneficiary bytes matches our own payment address, and that the deadline is actually has already passed, which means it's smaller than time.time. And then we decide, okay, because we can actually spend it, and because the time we have to wait until it gets spent is passed, we will spend this one and break, and there we have it. Now, okay, we are adding a collateral output, but we are doing this explicitly here. Again, PyCardano could do this for us. The redeemer, if we look here, the redeemer is ignored, so we just put anything again. And now we construct the transaction. We add a script input. We add our collateral, which is we could leave as well. Yes, the script input, a detail for you. The redeemer is here. The script we found and the UTXO is there. Then what we have to tell the builder now, because the builder does not naturally see this or tell this to smart contract, who will be the required signers. So what we actually do is we take the payment part from our own address, which we know is required from the smart contract to be a required signature. And then we add it to the transaction builder. There's a list of required signers, and there we just add our signature, and this will be later passed to the smart contract in the script context. And then, because now, again, we are handling validity, and per default, validity is infinite, we have to explicitly set a start for our transaction validity, which we will just set to the current state of the blockchain, basically the current slot, or the slot of the last block, and anywhere after this we can publish. And because we know that the time for the deadline has already passed, the slot of the latest produced block, which is like 20 seconds ago at most, this is just our reference point, and anywhere later we can submit. You could also, in theory, do the mapping yourself, compute from the current Unix epoch time to a slot number, but we just don't do it here, and we do this instead. We actually do compute the number of slots here, which is taking the slot length from our Genesis params and then doing some math to arrive at the number of slots, and we add this to the start time to obtain our time to live, which is the upper bound for our validity. So it would be sufficient to just specify the earliest time and make sure that this is this is after the deadline, but we actually specify the whole range, and then we build and we submit. That's it. Now need to look at preview. This is preview. I do recommend you to also use these debuggers to actually understand what your submission code is doing. It helps you a lot. And now you can see we have our contract that was spent here. We actually spent a lot more fees now because there was more complex interaction here. And yeah, all the data is here, the redeemer and the inline datum. So yeah, that's the first actually use we had of the vesting contract, which uses time and payment keys and signatories. I will now quickly go through what happens when we have the parameterized vesting, and we can actually see this only in the OpShin code, because we compile the same thing, and then when sending the funds to the address, we actually apply these parameters, compile again, and what we get from this is our parameterized vesting script. So let's look at the make vest code again. And now if we have the flag parameterized, it will create a new parameterized vesting contract, which is building building the parameterized vesting script using as an argument params.toJSON. So when you build a contract with so we can look at what this looks like when actually running the code. It would look like this. You have OpShin, and usually you just run build spending lecture questing, and then you get this. And when you run this with parameterized vesting, you will see in the blueprint that we generated that the datum is correctly specified. But then we also have parameters here, which is params. And this one has beneficiary and deadline. So what we can also do is during compilation provide a value for this parameter. And this we specify by using this this JSON syntax that we had for datums here. So actually what I can do is can just take this, let me just paste it here and bring it to one line. Now I cut this value and I provide this as a parameter during compilation. And now I get an error because the constructors are incorrect. That's because in parameterized vesting, we did not actually set the constructor ID to 0. Always set the constructor ID to 0 explicitly to avoid these pitfalls. Let's try this again. And now what is happening is that OpShin already provides this parameter during compilation. And now we look at the blueprint again. And okay, maybe it has basically realized that the sash should have changed at least. Let's have a look. Doesn't look like it. No, the blueprint actually stays more abstract, but as you can see, the policy ID has changes between the two versions. Let's close this. And now we have a different policy ID, because we have now correctly provided an argument, and yeah, this is also now updated. So we see the parameter, but this might be a bug in OpShin. So a pitfall when parameterizing smart contracts is that you don't provide all the parameters upon compilation. And this is why the blueprint usually lists the number of expected parameters. Because if there is a parameter left, then you shouldn't spend the smart contract. The problem is you can, because fundamentally the smart contract is a function that takes a number of arguments. And if it expects 4, like it expects the normal 3, and then it expects an additional 1. And if you don't provide the parameter during compilation, what you will get is a validator that has 3 out of 4 arguments applied and the 4th one missing. which is a function which doesn't throw an error because it's not executed. So what you will get is a contract that looks like it works, but it actually is an always validate contract. Long story short, be sure to run negative tests against your contract to ensure that they are also failing when you're trying to break them in a way. And if they are not failing, this might be the reason. You're providing parameters, additional parameters, but you are not correctly compiling them in. So yeah, the easiest way really is to make sure to provide them during the compilation, but you can also, there's apply script parameters function in the OpShin library, which you can use to apply parameters, and this will help you. Here we actually do it in the naive way. We just add this JSON to the end of the building command, and then we get a new contract. And the rest stays basically the same. So let's try. We just add the flag parameterized. We see now that there was a new script generated just for Bob, and what you should be able to see is this transaction went to contract XFX0Y, and due to the parameterization, the script address should now have changed. So if we would send another vesting funds without parameterization, okay, we cannot yet because because our last transaction is not on the chain. This is normal error. Right, this now goes to EX6, and we don't have to actually provide an informative constructor. Okay, still doesn't work. But this is now sitting at a different address, and it's not providing any interesting data, but still using makevest. When we provide parameterized, we will again reconstruct collect vest. We will actually load the parameterized vesting script, and yeah, one thing is we cannot really check the deadline because it has been meshed into the contract and then hashed. So we can, in principle, if we know the contract already, if we know the entire code, we can unwrap it and obtain the deadline. But to an outside observer, when the script has never been executed, they have no way of knowing what's the actual script behind this. So in our case, we will just try and spend this one. And the rest is the same, except that the datum that we attach, where is it? Yeah, the datum, we don't explicitly attach it again because it was embedded in inline, so nothing else really changes trying to spend this. And let's see, let's collect vest as Bob from the parameterized version. Let's see. Again, here it was locked. you might see the benefit of having a testnet where you have just 1 second block times, then don't need so much time to actually wait for a transaction to make it on chain. And there we go. And now, as you can see, we didn't provide any interesting redeemer, but still we executed a number of comparisons. And yeah, the script was executed correctly. Just now, we didn't really need to add any specific information. Okay. Now, if you look at the screen, you will notice something interesting. The script is 4 kilobytes, the transaction is 4 kilobytes, and most of this is the script. So in the next lecture, we will look at reference scripts, which will decrease the size of our transaction, and thus also the fees and the amount of space that the script takes up in our transaction. See you in the next lecture.